So welcome back to another problem. So the question is find the minimum in the rotated sorted array. So we have seen some similar problems regarding rotated sorted array. So we have to find the minimum. So find whenever it comes searching, we have to go for linear or binary search. To make it optimized, we'll go for binary search. So here the array is given like it is sorted in ascending order. So it's already sorted, that is 0, 1, 2, 3, 1, 2, 4, 5, 6, 7. So it is rotated. So rotation, as you all know how it works. So what we have to do is we have to find the minimum number from this. Like 3, 4, 5, 1, 2. The minimum number is 1, so we have to return that. Here 4, 5, 6, 7, 0, 1, 2, 0. So that's the basic approach for this problem. So we have to basically return the minimum number. So the first solution that comes to our mind is that we can use a linear search approach to find for the minimum value, but it is rotated and it will take time. When it is rotated like n minus 1 times, 0 will come here. So we have to travel n times. So we can have a better approach. As I said, we can go for binary search. So this is a basic level, a basic to moderate level binary search approach. So here we have to handle three cases. I have written here. First, when the array is already sorted. When the array is already sorted, we can check a condition directly. We have to check whether the array is already sorted. That's the first basic thing. For that, what we can do is if the lowest element is lesser than the highest element. If that's the case, we can directly return this no because that's the minimum element. That's one case, and this is the second case that I have set. So in this case, in the first iteration, 5 will be the minimum value. So the condition first we will be checking is, as I have told, whether we have to check if it is already sorted. If low is less than or equal to high, here it's not true. So we are going for the second condition, that is if the mid element is greater than the mid plus one element. If that's the case, we can return mid plus one element now. So I guess this is the breaking part here. That's all. It's not much complicated. We have to check these three conditions. If the mid element is greater than the mid plus one element, we are just directly returning the mid plus one element. And the next condition we can have is, look, if the first condition is not satisfying here, the low is not less than or equal to high, so it's not possible. The mid value is also not less than or equal to mid plus one. So what we are going to check is if the mid value is less than the low. Okay. So why I'm doing this means we know that the lowest value is not lesser than the highest value. 3 is not lesser than 2. So mostly it can come in the second part if that's the case. If the middle value is greater than the lowest value, 5 is greater than 3, that's true. So we are just shifting to the second part, this part, and we are recursively applying that same thing. That's the case, like we are just checking if the mid value, that's the third condition. If it's greater than the lowest value, usually in rotated array we went for that half, but here it's different because we have checked the condition whether the first value is less than or equal to last the value. As it became true, we came to this case. So when such a condition satisfies, like if the middle value is less than or equal to low, we are going for the next part, or else we will come to the first part where the minimum can lie. So that's the approach in this. These three cases, if we can handle, this problem can be solved. So that's what we are going to do. So first, the basic binary search approach we are going to do. So this is mid value. So first, as I have said, we are going to check that it's not about searching. It's not about directly finding a target or something like that. We have to check whether which is the minimum value here. So the first condition, case one, is to check whether the low is less than or equal to high. Like if nums of the lowest element is less than or equal to high, so in that case I'm going to return the lowest element. Now the second case will be to checking for checking whether the middle value is greater than the mid plus one value. this case, like we have to check if it is greater than the mid plus one value, as it is already rotated. This can be the maximum, and the next one can be the minimum. That's what it says. So if nums of mid, if that's the case, I'm going to return this mid plus one. Now the case 3 is, as both of those didn't satisfy, our condition that we have to check is if middle value is less than the lowest value. So if the middle value, nums of lowest value, in that case I'm going to the second part. So those are all the three cases that we are going to do here. So there won't be a negative condition in this case. I'm directly returning. Okay, so there is an error here. 312. At first, one will be the minimum, where the low is not less than or equal to high. Case one fails, and the middle value is not greater than or equal to mid plus one. Case two also fails. If middle value is greater than or equal to lowest value, that's also failing. So high will be mid minus one. Now I have to consider this value also. So I just have to take high is equal to mid. And there is one more case, like if it's only a single value, I'm just returning that value. It, it just go for off one. So there are better approaches than this, like for handling this and all. But this also satisfy the time complexity of O of log n, because you're directly checking, doing the binary search. There is nothing apart from that. It won't go for of n, and to the worst case also it will go for of log n. So that's it. If we can handle these three cases, that's how we can solve this problem. So thank you guys. I hope you have understood. So we'll see you again in the next video.